Welcome to Stride Threat Modeling Step by Step. In the next few minutes, we'll walk through how to systematically identify security threats in any system using the Stride framework. You'll learn the 6 threat categories, how to build data flow diagrams, apply Stride to each component, prioritize threats, and select mitigations. Threat modeling catches security issues in design before they become vulnerabilities in code. Let's get started. Let's start by understanding the 6 threat categories that Stride uses to systematically analyze security. Each letter in Stride represents a category of security threat that can affect your system. Spoofing occurs when an attacker impersonates a legitimate user, system, or service. This includes stolen credentials, forged tokens, IP spoofing, and email spoofing. Spoofing violates the authentication property. The system believes it is communicating with a trusted entity when it is actually communicating with an attacker. Tampering involves unauthorized modification of data. This includes modifying data in transit through man-in-the-middle attacks, altering data at rest in databases or files, and manipulating data in memory during processing. Tampering violates data integrity. The receiver trusts data that has been maliciously altered. Repudiation occurs when a user performs an action and the system cannot prove it happened. Without adequate logging and audit trails, a malicious insider can deny deleting records, a user can deny authorizing a transaction, or an attacker can cover their tracks. Repudiation violates non-repudiation, the inability to prove who did what and when. Information disclosure is the unauthorized exposure of sensitive data. This includes database leaks, error messages that reveal internal details, insecure APIs that return too much data, and sidechannel attacks that infer information indirectly. Information disclosure violates confidentiality. Data reaches parties who are not authorized to see it. Let's cover the remaining 2 Stride categories and the key concepts for threat modeling. Denial of service makes systems unavailable. Attackers exhaust CPU, memory, network bandwidth, or storage to prevent legitimate users from accessing services. Application layer DOS exploits specific vulnerabilities to crash services with minimal attacker resources. DOS violates availability. The system cannot serve its intended purpose. Elevation of privilege is the most dangerous Stride category. An attacker gains higher-level access than they should have, from regular user to administrator, from unauthenticated to authenticated, or from application-level access to operating system access. This often enables all other Stride threats and is the goal of most sophisticated attacks. The data flow diagram is your primary tool for threat modeling. It shows processes that transform data, data stores where information persists, external entities that interact with the system, data flows connecting them, and trust boundaries that separate different security zones. Every element in the DFD becomes a target for Stride analysis. Trust boundaries are where the most critical threats exist. They mark transitions between different trust levels, between the internet and your network, between user space and kernel space, between your application and a third-party service. Data crossing trust boundaries must be validated, authenticated, and encrypted. Most security vulnerabilities occur at trust boundaries. Now let's walk through the practical process of applying Stride to a real system. Threat modeling with Stride follows a structured 4-step process. Start by building a data flow diagram of the system. Identify every process, external entity, data store, and data flow. Mark trust boundaries where security contexts change. Include all entry points where external data enters the system. The DFD does not need to show every implementation detail. Focus on security-relevant architecture. The course walks through building a DFD for a complete web application. Walk through each element in the DFD and ask which Stride categories apply. Processes are susceptible to all 6 categories. Data stores are primarily at risk from tampering, information disclosure, and denial of service. Data flows are vulnerable to tampering and information disclosure. External entities are primarily spoofing risks. This systematic approach ensures comprehensive coverage. Not all threats are equally important. Prioritize using a risk rating method like DREAD, damage potential, reproducibility, exploitability, affected users, and discoverability, or a simple likelihood times impact matrix. Focus remediation effort on high-risk threats that cross trust boundaries and affect sensitive data. For each prioritized threat, select appropriate mitigations. Spoofing is mitigated by authentication. Tampering by integrity controls. Repudiation by logging. Information disclosure by encryption and access control. Denial of service by rate limiting and redundancy. Elevation of privilege by authorization and input validation. Document any residual risk for threats that cannot be fully mitigated. Threat modeling delivers the most value when applied at the right time in the development lifecycle. Threat modeling delivers the most value during design. Architecture decisions can still be changed cheaply. Security controls can be designed into the system rather than patched on later. Major threat categories are addressed before a single line of code is written. Research consistently shows that fixing design-level security flaws costs 10 to 100 times less during design than in production. Threat modeling existing systems is still valuable. It identifies threats missed during original design, prioritizes security improvements based on the actual architecture, and is essential before major changes or integrations. Existing systems often have trust boundary violations that accumulated over years of incremental changes without security review. Let's close with the most important lessons for STRIDE threat modeling. First, STRIDE's systematic approach ensures comprehensive threat coverage. By methodically checking each of the 6 categories against each DFD element, you avoid the blind spots that occur when relying on intuition or ad hoc brainstorming. The framework is the discipline that makes threat modeling reliable. Second, focus your analysis on trust boundaries. The transitions between different security contexts, internet to application, application to database, your system to a third-party service, are where the most critical and exploitable threats exist. Data crossing trust boundaries must be rigorously validated. Third, threat model during design whenever possible. The cost of addressing a security flaw increases by an order of magnitude at each stage of development. A design-level fix is cheap. A code-level fix is moderate. A production fix after exploitation is catastrophic. Shifting security left through threat modeling is one of the highest ROI security investments. And fourth, threat modeling is a skill that improves with practice. Start with simple systems to build familiarity with the process. As your expertise grows, tackle more complex architectures. The course provides progressively complex exercises that build your threat modeling skills from beginner to advanced. That wraps up our overview of STRIDE threat modeling. In the full Udemy course, you'll get 13 detailed lessons covering the complete threat modeling process, DFD building templates, and STRIDE analysis worksheets, progressively complex exercises from simple to advanced systems, and mitigation selection guides for every STRIDE category. Click the link below or scan the QR code to enroll and start finding threats before attackers do. Thank you for watching. If you found this overview helpful, subscribe to the channel for more content, and check the description for the link to the full course. See you in the next video.